In 2.7, we're going to talk about inequalities, and there's more than one way to write it. One is just as an inequality, so something like x is greater than 1, x is less than 1, but also you may need to do, or let's just go x greater than or equal to 1, x less than or equal to 1. It may also ask you to do it as interval notation. So when it's just greater than, then you're going to use a parentheses. And here, we're going to put a 1, comma, and then it's everything bigger than 1, so it's going to go all the way to infinity. With infinity, you always put a parentheses. If it's less than 1, then it's going to be negative infinity, comma, 1, and the parentheses. The parentheses and the less than, they mean that it's not, that the function or graph doesn't include the 1 or whatever number, but it includes everything up to it. So here, it's 1.0000001 up to infinity, and this is from negative infinity all the way to 0.9999999, going on forever. Now, if it's also, or if it's including that, then you need to put a bracket, because that means it includes the 1. And then again, infinity. Infinity always has the parentheses. And then here, it's negative infinity to 1 with a bracket. Now to graph these, if it doesn't include the number, then it's going to have a circle. So here is the 1. This is 0. So it's greater than 1, so it's a circle, and everything more than that. If it's less than 1, everything less than 1. If it includes the 1 or whatever number, then you're going to use a solid dot. So it's going to be a solid dot and everything bigger than 1. If it's less than 1, less than or equal to 1, then it's the solid dot and everything over like that. So these are the main ways that you're going to see it. And it's going to ask you either to put it in interval notation, which means you're going to have to do it like this, or as an inequality, which means you'll have to do them like these. Now you may also have some where you have something like, in parentheses, -5, 3, and then a bracket. So that means it's everything that's greater than 5 and less than or equal to 3. So the way to write this would be -5 is less than x, which is less than or equal to 3. And to graph it, we have a -5 here, a 3 here, and the 0. The 5, as we saw, it doesn't include the 5, so it's a solid dot. It does include the 3, or it's a hollow dot with the -5. It's a solid dot with the 3, and then we draw the line through there. Okay, so those are just the basics. Then we're going to do some that have inequalities as far as, they're not equations because they're not equal, but they're inequalities. And we have some of the same properties as we do with equations. So if we start that A is greater than B, then A plus C is still going to be greater than B plus C, and A minus C is still going to be greater than B minus C. So if we either add or subtract the same thing from both sides, we're still going to have the same inequality. So likewise, if we have A is less than B, then A plus C is going to be less than B plus C, and A minus C is less than B minus C. For example, if we have 4 is greater than 2, and we add 1 to both sides, 4 plus 1 greater than 2 plus 1, and we see that 5 is greater than 3, so we see that that's correct. If we had 8 is less than 10, and we subtract 2 from both sides, 8 minus 2 less than 10 minus 2, we're going to get 6 is less than 8. It's still true. So in that situation, that all works. Now there's a difference when we're multiplying and dividing. So for multiplying and dividing, we're going to flip the sign if our C is negative. So what that means is that if we're going to multiply both sides by a negative something or divide both sides by a negative something, then we're going to flip the sign. So there's going to be two different ways to do this. We're still starting A is greater than B or A is less than B. Now if C is positive, then A times C is greater than B times C, and A divided by C is greater than B divided by C. Likewise, A times C is still going to stay less than B times C, and again, this is if C is positive, and A divided by C is less than B divided by C. So if we have something like 4 is less than 9, and we multiply both sides by 2, 4 times 2 less than 9 times 2, 8 is less than 18. So we see that that still holds. Let's look at what happens if we multiply or divide by negative. So let's do an example first. I'm going to start with 2 is less than 3. I'm going to multiply both sides by a negative 1. Okay, so now I have negative 1 times 2, and I have the 3 times negative 1. So I'm going to see what happens when I do the multiplication. I have negative 1 times 2, which is negative 2. 3 times negative 1, which is negative 3. But now we know that negative 2 is bigger than negative 3, so we have to change the sign. So that's the big thing here. And I'll do a division one as well. Let's say 8 is greater than 4. I'm going to divide both sides by a negative 2. Now I have negative 4 and negative 2, so I have to change the sign to be negative. So our identities here, our properties, is if C is negative, then, and we start with A is greater than B or A is less than B, then AC becomes less than BC. A divided by C becomes less than B divided by C. And on this one, AC now becomes greater than BC, and A divided by C becomes greater than B divided by C. If you ever struggle with one of these, just do some simple ones like I did with the 4 divided by 2 and 4 times 2 and so forth, and go from there. Now, those are just the basics. Now let's do one where we actually have to solve for x. So say we have 7x is less than 42. So what we need to know is every value of x that will make this statement true. So we're going to solve it just like we did before. X, and 7 divided by 7 is 1, so we're just left with x. We have 42 divided by 7, which is 6. And we divide by a positive, so x is less than 6. And the way we can check this is put some number that's less than 6 in here. I'm just going to put a 0 because that's easy. 0 times 7 is 0, and that is less than 42. If I put a 10, 7 times 10 is 70, which is bigger than 42. So we know we got this right, and we can't do the actual 6 because if we put that in, then it would equal 42. Let's say that we have negative 10 greater than or equal to, or 10x, negative 10x greater than or equal to 50. So I'll divide both sides by a negative 10, We still have x on this side. Now we have a negative 5 on this side. Now let's say I don't remember whether I need to change the sign or not. So what I'm going to do is a number that is bigger than negative 5 that's easy to multiply is 0. So I'm going to say negative 10 times 0 is 0. 0, though, is less than 50. So I need to change the sign. So that's just one way to know if you did it correctly, is by plugging a number that's bigger than or less than into the number and see if the inequality still holds. Unless you get the answer of 0, that's the one I would usually use because it's the easiest. Okay, then let's say that we have something like x plus 1 is less than 17. We have to solve for this, but we also have to graph it. So I'm going to subtract 1 from both sides. X, we always keep the same direction, and it's going to be 16. And to graph this, we go to 16. Because it's only less than, then it is a hollow dot, and it's everything that is less than 16. Let's say we have 8x plus 1 is greater than negative 31. So I'll subtract 1 from both sides. We get 8x is greater than negative 32. Divide both sides by the 8. X, here we're going to get a negative 4. Now this is one where you may get confused because there's a negative sign in here, but we're dividing by the positive. So we're going to keep the sign in the same direction. So let's put this into here. Put a 0 because 0 is bigger than negative 4. So we're going to see if we're right. 8 times 0 is 0 plus 1 is just 1. And 1 is bigger than negative 31. So we know we got the sign right. So we have 0, 1, 2, 3, 4, negative 4. Again, it's a hollow. And it's everything that is bigger than that. Okay, now let's say that we have 4x is less than or equal to 9x plus 17. So we want our x's on one side and our numbers on the other. So I'm going to subtract 9x from both sides. And I'm going to have a negative 5x less than or equal to 17. Now I divide by a negative 5. So x, and on this side we're going to have a negative 17 over 5. We have to change the direction of the sign so it becomes greater than or equal to. If we were to graph this, we'd have 0, negative 17 over 5. It's a solid dot, and it's everything that's greater than. But if it asks you to put this as interval notation, we see that it's a greater than or equal to. So we're going to have a bracket, negative 17 over 5, comma, and it's everything that's bigger than that, so it goes up to infinity. And again, you put the parentheses for the infinity. Now let's say that we have 8x minus 2, open parentheses, 5 minus x, close parentheses, less than 4, open parentheses, x plus 9, close parentheses, plus 6x. So we're going to do this just like we did the equations in the same order. We don't have any exponents, and we can't really do anything inside the parentheses. So we're going to distribute. We're going to say 8x minus 10 plus 2x, because it's a negative 2 that we're distributing. We keep the negative sign because we haven't done anything that's moving from one side of the expression to the other. And then 4 times x is 4x. 4 times 9 is plus 36, and plus 6x. So now we need to combine like terms on both sides. We have 8x plus 2x is 10x, minus 10 is less than 4x plus 6x is 10x plus 36. Now we're going to move this 10x to that side and this 10 to this side. So minus 10x minus 10x plus 10 plus 10. We get 10x minus 10x is 0. Minus 10 plus 10 is 0. And we still have the less than. 10x minus 10x is 0. 36 plus 10 is 46. So 0 is less than 46. Now this is a little bit different than we did before, because before when we had something that was different on both sides of the equal sign, that meant that there was no solution. This means, though, when it's an inequality, if the inequality that we make is true, then all real numbers, any number that you stick in for x will work. And we'll still get 0 is less than 46. So to write this, we'd say negative infinity to infinity. You might say all real numbers, and to graph it, it's just the entire number line. So this one is a little bit different than what we did for equations, because it could be all real numbers. If we get something like 46 is less than 0, then it would be no solution. Okay, so now let's say we have 3x plus 6 over negative 3 is greater than 10. So the first thing we do here is multiply both sides by a negative 3. And these negative 3's cancel. We get 3x plus 6. On this side, we're going to get a negative 30. Because we multiplied by a negative number, we have to switch the direction. So we have less than negative 30. Now we subtract the 6 from both sides. And we get 3x is less than negative 36. Divide both sides by 3. And we get x is less than negative 12. And that would be our answer here. Okay, so you may also have, you'll have some word problems as well. Whenever you see at least, no less than, or is the minimum, whenever you see one of these, that means you're going to have greater than or equal to. Because it could be, let's say it's at least 10, it could be 10 or more. No less than 10, it has to be either 10 or more, and 10 is the minimum. Then that's what you're going to use, is greater than or equal to. If you see at most, no more than, or is the maximum. In these situations, it's going to be less than or equal to. So it's x is at most 10. So it could be 10, 9, 8, 7, or anything lower. All right, and that is it for section 2.7 on inequalities.